Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC C1245-1C relates to an issue with the brake pressure sensor 2's power supply in Honda Civic models from 2022 onwards. This code indicates that the voltage supplied to the brake booster pressure sensor 2 is outside the acceptable range. The brake booster pressure sensor 2 plays a vital role in determining the brake system's pressure, ensuring responsive braking. Located within the brake system assembly, the efficiency of this component is crucial for vehicle safety and performance. When an issue is detected, the electric vacuum pump control unit stores the DTC, flagging a potential problem in the braking system. Understanding this code is essential for diagnosing related faults and ensuring accurate repairs. The DTC C1245-1C indicates that the brake booster pressure sensor 2 is receiving an incorrect voltage supply, triggering the electric vacuum pump control unit to record this abnormality. This sensor is essential for monitoring the hydraulic pressure in the braking system, influencing braking efficiency and effectiveness. Its location is crucial. It is found within the brake assembly, directly connected to the brake lines. The electric vacuum pump control unit's role is to maintain vacuum levels for optimal brake operation and also to flag any discrepancies in sensor readings. If the voltage supplied to the sensor is not within the specified range of approximately 4.5 to 5.5 volts, the system will identify a fault, leading to the generation of this DTC. This specific error code highlights the importance of a reliable electric supply to vital brake components. Various factors can lead to the DTC C1245-1C being triggered. A faulty brake booster pressure sensor 2 is a primary suspect, as this component may fail, leading to inaccurate voltage readings. Wiring issues might also cause this fault, particularly if there are shorts or cuts in the cables supplying power to the sensor. It's crucial to inspect the related circuits comprehensively, as a small compromise in the wiring could affect the overall system. Lastly, the electric vacuum pump control unit itself may develop faults. If its function is compromised, it won't correctly interpret or manage the signals coming from the brake pressure sensor. Assessing each of these components is necessary to pinpoint the exact cause of the DTC. Several symptoms may arise from the C1245-1C DTC, indicating concerns with the brake pressure sensor 2. Typically, one of the first observable signs is the illumination of the brake warning light on the dashboard, which serves as an immediate notification to the driver. In addition to visual alerts, drivers may notice increased effort required to press the brake pedal, suggesting that the braking system is not functioning optimally. This increased effort signifies that the hydraulic pressure may not be correctly managed by the brake booster pressure sensor 2. Additionally, there may be intermittent brake performance issues, putting the vehicle's safety at risk. Recognizing these symptoms early on is crucial for ensuring timely and effective repairs to prevent further complications. The first troubleshooting step when addressing the DTC C1245-1C is to conduct a confirmation procedure to assess the system state. Start by turning the vehicle to the on mode, which activates the electrical components without starting the engine. After this, switch the vehicle to off, lock mode, and allow a pause of at least 2 seconds. This brief waiting period is essential, as it allows the system to reset and clear any temporary glitches that may have influenced the electrical readings. Immediately after waiting, turn the vehicle back to the on mode. This sequence helps ensure that the system is ready for the next steps in the diagnostic process. Performing this confirmation procedure is critical in establishing a baseline for further inspections. In the second step of troubleshooting DTC C1245-1C, the brake booster pressure sensor 2 requires careful inspection. Begin by disconnecting the sensor's 3P connector, ensuring that all current is safely cut off before proceeding with your checks. Once disconnected, concentrate on examining the female terminals for any signs of corrosion or damage. This can frequently lead to communication errors between the sensor and the control unit. Following this visual inspection, perform a voltage output inspection in IG mode. The expected output voltage should fall within the range of approximately 4.5 volts to 5.5 volts. Any deviation from this range indicates an issue with the sensor itself, requiring further diagnosis or replacement. This step is crucial as it determines whether the sensor operates effectively or if it needs replacement before moving on to check other components. The third troubleshooting step focuses on inspecting the external circuit associated with the brake pressure sensor tube. Begin by disconnecting both the electric vacuum pump control unit's 30P connector and the brake booster pressure sensor 2's 3P connector, ensuring all involved components are out of circuit for safety. With the connectors removed, you'll now check for any shorted wires, especially within the sensor 2 supply circuit. Utilizing an open shorted wire inspection method, measure for any continuity issues or shorts by referring to diagnostic specifications. Check whether the sensor 2 supply is shorted to power or if the sensor 2 signal is shorted to ground while the vehicle is off. Any detected abnormalities in this circuit necessitate thorough cable inspections and repairs. This step is critical for maintaining reliable braking functionality, as wiring issues can lead to systemic failures. In the final troubleshooting step, the electric vacuum pump control unit must be evaluated if prior inspections yielded normal results for the sensor and wiring. This component is essential for maintaining the right vacuum levels necessary for effective brake performance. Begin this inspection by examining the control unit itself for any signs of physical damage, burnt connections, or other issues that may affect its functionality. Use diagnostic tools to check for any additional error codes that the unit may provide, which can give insight into its operational status. If this unit fails to pass inspection or shows irregularities, it is likely the primary cause of the DTC. Proper assessment of this unit is crucial, as replacing it may resolve the braking pressure issues if all previous checks validate that the sensor and wiring are functioning correctly. After completing all troubleshooting steps for the DTC C1245-1C, it's essential to conduct a thorough verification process. Begin by clearing the stored DTCs from the system using a diagnostic tool designed for Honda vehicles, which will reset the system after repairs. Following this, run a series of brake system tests to evaluate overall braking performance and ensure that the issues have been fully resolved. These tests might include braking response checks and monitoring for any warning lights that may reappear. Confirming that the braking system is operating successfully without triggering the DTC again ensures that the vehicle is safe for use. This final verification step is critical, validating the integrity of all repairs performed. It reassures the technician and the vehicle owner that the underlying issues have been fully addressed. Preventive maintenance plays a vital role in prolonging the lifespan and functionality of the braking system, specifically in relation to issues indicated by DTC C1245-1C. Regularly scheduled brake system checks are highly recommended. They can preemptively identify worn components or irregular sensor readings before they lead to serious failures. During routine inspections, pay close attention to wiring connections and solder joints, as these can corrode or wear over time, leading to malfunctions similar to those indicated by the DTC. Additionally, routinely monitor the performance of the brake booster pressure sensor by checking output voltages during standard checkups. Adopting these preventive maintenance practices can provide reassurance of your braking system's reliability and keep potential issues at bay, ensuring smooth and safe driving conditions. In summary, understanding the DTC C1245-1C and its implications is crucial for maintaining the safety and performance of the Honda Civic 2022 and onward models. It highlights a problem with brake pressure sensor 2 that could lead to compromised braking performance if not addressed. Following the outlined troubleshooting steps is essential for pinpointing the exact cause of the error and effectively resolving the issue. It's equally important to emphasize the necessity of regular vehicle inspections and preventive maintenance practices. By doing so, vehicle owners can ensure that similar problems do not recur, thus maintaining the safety of their driving experience. Ultimately, keeping your brake system in top condition is vital to ensuring safe travels on the road. Please like and subscribe to the channel. See you next time!